Okay, welcome back for the second part of Jacobs Chapter 5, Example 5.2, Decision Trees. And we're going to apply present value concepts to the same problem that we just finished. What you see here is right where we finished off Part A of this. We just finished completing the decision tree that accompanies the problem that we had. And here I'm showing McGraw-Hill Connect Live. I'm actually there with the online book, okay? So if you're going along by the book, you can see page 18 here. And where we ended up in the end of part A of this is, if you read the description of the problem, they work all the way down through this part that I just highlighted. Okay, so that finishes up where we got to in part A of the video, okay? We're going to be now taking a look at what they describe from here on down, from this the due to the 5-year, okay? So let's go through the narrative here. What are they telling us? Due to the 5-year time horizon, it may be useful to consider the time value of the revenue and cost streams when solving this problem. If we assume a 16% interest rate, the first alternative outcome, what was the first alternative count? The first alternative was the first choice we had, was moving. So they're saying move now and you encounter strong growth. And all of a sudden they throw you this, it has a discounted revenue value of 428, okay? Let's work that out, okay? I want to bring in the concept here that we talked about in Chapter 3, the base case financial analysis, okay? And that's the other place where we saw discount values being used here. And in that problem, what we did is we created a cash flow statement, and what I'm going to do is represent, I'm just going to colorize some of these cells here, okay? And I'm going to drop in some, not too obnoxious color here. Okay, so there. All right. So what this is representing is a number of columns across the top. Each column is a period. Okay, if you go back to the base case analysis, that's financial analysis, not financial analysis. Okay, so this is just to represent the big worksheet that we have. And up top, we did some graphics and we showed some periods. We grouped together some of these periods that we were using, and we grouped them into segments of a project. Okay, if you remember, you can draw really quite nicely. You can draw, if you colorize these things, you can talk about a phase that might be. All right, that's good enough. We might talk about a 4 quarters in the development phase and whatnot. And what we did was, after we drew the graphics up above, the pictorial of it, is we kind of separated out the next part. Okay, so we just drew a line in there. Okay, so the first part was pictorial, second part was analysis, and for every quarter and for every phase, we dropped in some numbers. For instance, we were spending out $1,000, and we're going to put it in there. Out goes, or we're going to put in there as 1,000. Okay, and we might have had 4 quarters of spending. I'm making the numbers up here, right? And then we got into ramp up, and we might have been spending another 2,000 in ramp up. Okay, and let's say that went for 4 quarters. Okay, and then we got into production. Here, let's say production was $5,000 a period. Okay, I'm going to take that out, even though it's beyond our little gray boxes there. Okay, but at the same time that production started, we also had sales start, and let's call that 10,000 a month. Okay, so that's positive, right? And that goes out ad infinitum, because your production and your sales go out ad infinitum. Production, sales. Just put those in here. This was deval. This was ramp up. Okay? I think those are the 4 things that we did. Now, if we sum these up, these columns, okay? This is what we did in that financial analysis there. Okay, and we saw, if we sum all those columns up, I want to paint this a little bit better so it'll be nice to your eyes. Okay. Okay, all right. So these are our 4 phases: develop, ramp up, production, sales. And we had this varying cash flows until it goes to steady state out here. And every quarter from there on out, we're going to make $5,000. Okay? So we're kind of netting it out. Our net cash flow there was that. And then we discount them. Okay, so that's what I'm getting at here. So this is period 1. Okay? So what we're going to do is we're going to discount the net cash flows per period. This is each one of these numbers is netting out a period, the column ahead of it, on top of it. Okay. So we want to bring back to today the present values, and we want to put those in here. Okay. So if we do it the long form and we don't use the formula inside Excel, that would be equal to that, our cash flow, over some number here. Okay, and what that number would be is 1.16. That's the 16% annual rate that we're using. Okay, and we're raising that to the period, which would be 1 at the end of the period. Okay, so we just calculated by hand the present value of the period 1 outgo, which we spend at the end of the period. That's what we're saying there, okay? So let's see here. So I'm going to grab this, but we're going to have to modify the formula for each of these. So this is the second period, so we have to raise our denominator up into this number. The number of period is 3 for this one, so we raise it to the third. That means that we're regressing it back 3 periods here. 4. There's easier ways to do this, but I'm going to go the longhand way just to show you how it's done. Okay, that's the 4th period. We're up to 5 already. I think that's the 5th. So this one want to make 5th. This is the 6th. Okay, so this is a little practice to understand what's going on. Get to see this again. Is 7. And bring back, finally, the last one we'll do is the 8th. And it all looks good to me, okay? And we're going to change all of these numbers into dollars, but I don't want the dollar sign. It's quite annoying. So we don't want this at all. And we'll go 2 places. Boom. Now we have our money showing, okay? So down here, when we're down below this, we might paint this as a faint shade of yellow just to get our eyes, go easy on our eyes, okay? It separates out from the data in the table up here, core data of this. Well, hello and good afternoon. This is hang on just Professor Peter Gregory for Business 3010 Production Systems. And here's a video, another video just started of one of the major topics for Chapter 5. Sorry about that, but I'm not going to go back and redo this because it takes hours to get these done. I've battled all day with software to be able to get to this point. So anyway, sorry for that interruption there. I'm about ready to post to YouTube Part A. That's what just started running here. It just finished rendering, and I'm going to send it up to YouTube and give you the link for that, and also post the PowerPoint, anything else you need here, okay? Okay, so I'm sorry for the interruption. Back to here, what we've done is we've summed up every quarter's or every period's cash flows, and then now we've discounted them, okay? So we want to do a calculation on this. Let's take a simple sum of the cash flows after 8 periods. So that's going to be equal to simple as that, okay? And then I can just drag and drop this, and we can get the sum of the values of these cash flows when we use a discount value of 16%, okay? I'm not really sure how relevant 16 is because our interest rates and inflation rates are far below that right now for general. I mean, I'm sure you could get a loan where they're going to ask you 16%, and that might be your best rate right now regarding your risk. It, of course, has everything to do with the risk, okay? So a little business chat there. Let's get on to the problem. In our actual problem, our cash flows, what we want to say is we want to start discounting these cash flows that we're going to have in the future, okay? And the book just runs right through here, and they use this number that you don't even have access to the table. It talks about Appendix E down here, and you don't even have that. That's why I did some work for you right now. Put that together today so you can have it. For those of you who don't have the printed book in the hybrid course, it's not required. Okay, so I had to help you out with that. Okay, and so they come up with this number, $428, and who really, $428,000, 487. Okay, 428.47. Okay. And where did this number come from, and how did we get there? Okay. And they throw in this, oh, by the way, minus 210. I think that was pretty quick, unless you're financial geniuses. I just want to make sure you have a fair shot at this. Let's look at what they're talking about here is the one path. Show the path they're talking about. They're saying path by path, you have to show what the discounted values are here. Okay. So we're going to go through the path where we do the move, and there is a strong reaction, strong market. Okay, and so our cash flows through that were $195,000 for 5 periods. So now I'm doing a completely different problem. I wanted to do the base case up here where your cash flows were different every month. Now we're doing one where every month you have the same amount coming in, and we consider that in the world of finance, evaluation, analysis, an annuity, because we can do something different with this. All right, and that's where that strange 3 point something number came from, and that's what this lesson is about. Okay. So if we could go through and we could discount each one of these very much the same way. So Control C, Control V, okay. Okay, it's telling me that it wants a broader column there, and I'm going to go back and make that a number format, rather a currency format, and just like that, boom, okay. So now everything lines up better. Okay. And what we're going to do is we're going to discount all these values. Boom, boom, boom. Okay. So 16% is the number in our problem from example 5.2. I took the cash flows, and after 5 years, I discounted them here. Let's sum them up over here. I'm going to still use the same column over here. Okay. And that way I can just Control C and Control V. V. Got to widen up the column there, okay? And lo and behold, things are working because $975,000 is 5 times these numbers. That's working. But if we add up these present values, I need to go in there and change the equation because I copied them, okay? So that's the second period. I have to raise it to the 2. This is the third period. I have to raise it to a 3. We went all the way through this in the other one. This one to the 4th. We're basically discounting it for 4 periods back to the present, and the 5th one is raised to the 5th. Okay, so I'm using the primitives. I'm using primitives in Excel to calculate, and I think it shows you better as to what the discount is going on. What's going on with the discount rate? Okay, and again, this file will be posted. You can go into this file and you can go into my cells and see how we did this. Okay, so now I corrected the index here, what number the denominator was being raised to, and we got $681,228. Where did they get the number 428 from? Okay, well, what we had to do was our payment to get there was $210,000 at day 0. It's not, there's no time involved with the payment. So what we need to do with the investment of $210,000 is just simply subtract it at the beginning. And I'm going to actually use the reference up here. Okay. And there we get $471,000. Okay, I found a bug. That's why the number isn't correct. Here, I'm going to come back here. And this cell here, when I typed it in, I did not do a shift on it. And that's why our numbers were off. Or I deleted it, it looks like. Okay, so things happen. Boom, all right. All right, now that I corrected the bad cell there, I recognize there was something going on. I run it up, 638,000, etc. when we subtract out from that the $210,000 it took for the investment, and again, that was at time equals 0, so there's no time. You don't discount that 210. You come out with the value of that project being $428,000, and that is how you get to this $428,000. That's how they got there. Now, I'm going to show you something different. Here's a learning experience for you. You're going to have to do these problems, and I'm going to ask you to do the discount rate on there. So this other table that I have in here is kind of neat, okay? And what it shows is a shortcut. You can use these tables. If you did this every day, all day long, you just have a table sitting there because you wouldn't want to calculate all of it, okay? So what this table does is it says, let's break down a table where we show across a bunch of different interest rates from 1% to 20%. I just made this, okay? Not a big deal, all right? Then let's say, how many total periods are we looking at? We're talking about annuities here, okay? And that means every month or every period you have the same payment. And that simplifies the problem, the challenge that we have, because if you look at this cell that I typed in here, this is a master finance equation for when you're doing annuities, just like we're doing here when all the payments are the same. You can only use this when all the payments are the same. Okay? So what we look at is the number of periods is the total number of periods that we're interested in, and in our case it would be five periods because we have 5 years, all right? And if we come all the way over here to the column for the interest rate of, or discount rate of 16%, 0.16, and do the intercept there, okay, there's this number, 3.274, etc., okay? Now, what does that look like? That's a multiplier, okay? If we're offering, if there's no discount rate involved, like when we first did it, and I come back to our sheet, come back here, okay? When we were doing no cost of time for money, you know, the time cost of money here, when we weren't doing that, well, all we did was multiply the period inflow times 5. What this other number represents is, if you want to discount over 5 years, a constant payment every period of whatever it was, $190,000. Instead of multiplying by 5, multiplying by 3.274, okay? So theoretically, if we come back to our page here, we calculated it with the brute force method, the Neanderthal method here, okay? We calculated this. And if we do it correctly, then what we should be able to do is take the payment, any one payment, it's a regular payment here, and we're going to multiply. I'm going off sheet here. I'm going over to the table and I'm grabbing this, bang, okay? And just hit enter. And look at that. So using the table and using brute force method of primitive equations, we come up with the same number. So that's an explanation of how to use this table if you don't want to go through the complete Neanderthal calculation. I highly recommend you know how to do this and do it for practice and get good at it here. So you have a command of that. It's really good. But basically, you could have used, when you have these constant payments here, you could have used the table, which they used in the book. That's the part they don't explain. Okay, so that's why I made this video. All right. Okay, so what we basically did was we discounted. They now use a different table or a different graph here, okay, for this new calculation, okay? So whereas up above here, we did this all out in Part A, the current values of 5 years worth of strong growth with a move, less the cost of $210,000 was $765, okay? What we're calculating down here, here's that $428,000 that we just calculated, okay? All right, and then we can go through each one of these the same way now. We can go through all these payments, and what happens is, I'm not going to go through all that, but you should and could for the exercise of it, and you might see that in a homework or quiz or final question, all right? But if we come back over to the book here, you can read the numbers down here, okay? So they went through and they did the discounts correctly with coming up with these numbers. And what they discovered is that when you do rerun the whole problem here, that you end up with an outcome of $460,000. It did not change the output of this or the outcome of this, but you should be aware of how to run this. The tricky part is in here, okay? So I went through that in some detail in Part A. For Part B, you should be able to go through there, what I just covered here, and figure out how to get these numbers, okay? So I'm not going to run all the way through there. It's already 20 minutes into this video. I had a little error I had to correct there, but I think we're good for that. Thank you for listening. I hope this helps.